This lesson is verify U1, U2 is an orthogonal set. Find the orthogonal projection of Y onto span U1, U2. So here's Y, this is U1, and this is U2. First, we need to find, is it orthogonal? So dot product of U1 and U2, just multiply 1 times -1 here plus 1 times 1 here plus 0 times 0 here. And then after that, simplify, so it becomes 0. Since it is 0, then it is an orthogonal set. Again, to be orthogonal, it has to equal 0. Next, we're going to do orthogonal projections of Y onto span U1 and U2. This is the formula, and this is called orthogonal decomposition. This theorem has two parts. For now, we're only going to do this first part. There is a second part to this, but for now, orthogonal decomposition, we're just going to do this part only. There is a second part to this theorem. So this is the first part of orthogonal decomposition theorem. There is a second part. We will do that later. So this part is pretty much the same thing. We're just doing dot product of everything. So let me move this down here just a little bit. So Y dot product of U, Y dot product of U1 divided by U1 times U1 itself again, and then multiply U1 again, plus Y times U2 divided by U2 times itself twice, and then times U2 again. So here is my Y, here is my U1, here is my U2, okay? So Y times U1, Y times U1. So -1 times 1 plus 4 times 1 plus 3 times 0 right here. And then simplify it, it comes out to be 3. U1 times U1, so 1 times 1, okay? Oh, I'm sorry. Let's do Y times U2 just to keep them in order. So Y times U2, again, I'm just going to keep them in order. So Y times U2, so Y times U2, Y times U2, so -1 times -1, 4 times 1, 3 times 0, okay, and then simplify, comes out to be 5. Now U1 and U1, so this right here twice, so 1 times 1, 1 times 1, 0 times 0, simplify, comes out to be 2. Next, U2 times U2, so do this twice, multiply itself twice, so -1, -1, 1 times 1, 0 times 0, which is here, all the way across, gives me 2. Now we have all the numbers to its variable, we just substitute them in. So Y times U1, 3. U1 times U1, 5. And then U1 is this plus Y times U2 right here, 5, all over U2 times U2, which is here, 2, and then times U2. And then after that, just multiply all the way across and add. So 3 over 2 times 1, 3 over 2, 3 over 2 times 1, 3 over 2, 3 over 2 times 0, 0. 5 over 2 times -1 is this. 5 over 2 times 1 is this. And then 5 over 2 times 0 is 0. Now just add across. So since the denominator are the same, that makes it easy. So 3 subtract -5 is -2. -2 divided by 2, -1. 3 plus 5 gives me 8. Divided by 2 gives me 4. 0 plus 0 is 0. So this right here is the orthogonal projection of Y onto span U1, U2. Again, this answer right here, written as Y hat. So Y hat is orthogonal projections of y onto span u1 and u2. One more time. This is the answer that belong to y hat, and y hat is orthogonal projection of y onto span u1, u2. This formula is called orthogonal decomposition, and this is only part one. There's another part to this. Okay, so one more time. This answer is y hat. Y hat is orthogonal projection of y onto span u1, u2. So in this example, you have to find orthogonal set. After that, find the orthogonal projection, which is this y hat right here. Okay, so one more time, you have to do two things. Find orthogonal. Is it orthogonal or not? After that, find y hat. Okay, and this is the solution to y hat. Y hat is called orthogonal projections of y onto span u1 and u2.